Hello, everyone, and thank you for joining the webinar today, hosted by the Ray, with our corporate partners at Cox Automotive, Pirelli Tire, and Novelis. We are so excited to be with you today talking about opportunities for circularity in transportation. And I'm joined by three fantastic experts and leaders in the field of transportation today who are going to be talking about areas for circularity to thrive in the transportation sector as we move through a transformative and disruptive time in transportation. My name is Allie Kelly. I'm Executive Director of the Ray, and I am so excited to be with you here today to lead this conversation with my close friends and colleagues. We can all agree that circular economy practices have disrupted and transformed global industries, including fast fashion, plastics packaging and plastic waste, and food waste. However, circular economy practices in transportation have not yet scaled as it relates to vehicles or transportation infrastructure. So why is now the time for circularity in transportations? Historic investments will be made in transportation and energy infrastructure on the order of trillions of dollars, a once in a century opportunity in the United States. Also, this is a disruptive and a transformative time in transportation itself as we move quickly to electrification and as we move to smart mobility that is ubiquitous. It's becoming more common, like the smartphone. We see consistent advances in connected and autonomous vehicles. And in this country, we've spent some time thinking about EV battery recycling and second life EV batteries going into energy grid storage. We're thinking ahead to what happens when EV penetration in the US goes from 1% to 30% or more over the next decade. And we've got some experts who are going to go deep on used batteries, scrap tires, and aluminum, which really means that we're going to be talking about rubber modified asphalt, energy storage, and lightweighted EV frames. So let me take a minute to introduce our panelists. First, we have Maureen Klein, Vice President of Public Affairs and Sustainability at Pirelli Tire. Maureen chairs the board of the Tire and Rubber Association of Canada. She leads the Sustainability Task Force for the US Tire Manufacturers Association. She's a former Europe correspondent for the Wall Street Journal, an alumna of Al Gore's Climate Reality Project, and co-chair of the board of Yale Blue Green, which is the network of Yale alumni who are interested in environmental and sustainability topics. Welcome, Maureen. We also have with us Stephanie Valdez-Streety, who is Director of Mobility R&D at Cox Automotive. Stephanie chairs the Cox Automotive Corporate Responsibility Council, and she oversees the Corporate Go Green Council. She is on the board of directors for EarthShare Georgia, for the Institute of Georgia Environmental Leadership, and for the Georgia Tech Ray C. Anderson Center for Sustainable Business Advisory Board. She formerly led corporate social responsibility strategies for Nissan North America and for Manheim. Thank you for being with us, Stephanie. And finally, Jamie Zinzer, Vice President of Global Automotive Sales and Marketing at Novelis. Jamie has over 25 years in the automotive industry. She's the former Chief Commercial Officer and VP of Global Engineering at Dura Automotive. She's a mentor for Women of Tomorrow and First Robotics, and she was named one of Automotive News 100 Leading Women in 2015 and 2020, and one of their 2019 Rising Stars. Thank you for being with us, Jamie.
Thanks, Allie.
So I'm so excited to get into this conversation today, and in the last couple of minutes of this introduction, before we get into hearing from each of these leaders and seeing the information that they're ready to present to us, here are just some quick facts to frame up the conversation today. So first of all, a battery on an electric vehicle that is technically considered end of life for that vehicle still has about 80% of its original energy capacity. Did you know that aluminum can be recycled forever, over and over again? And recycling aluminum from manufacturing room floors and from waste streams like Coke cans requires only 5% of the energy and generates just 5% of the carbon emissions as producing primary aluminum. And this is a new area of research. We're doing ongoing data collection, but the data suggests that electric vehicles have accelerated tire wear. On average, EVs wear tires twice as fast as gas-powered counterparts. And everyone assumes that it's because of the weight of the battery, but it's really driven by the engineering of electric vehicles. It's the instant torque, the instant power from the motor to the wheel. And Maureen is going to talk more about tire waste streams and viable end markets, but we've got to wrap our heads around waste streams. We've got to wrap our heads around the number of scrap tires in America and the fact that that waste stream is going to potentially double or nearly double as we electrify across all vehicle classes. So Maureen, let's begin with your perspective on tires, sustainability, and circularity.
Thanks, Allie. And it's so exciting to work with Allie, who is the most passionate woman in the automotive industry. You didn't introduce yourself, but I think, you know, I always said if she were running for office, I would vote for her in a minute. Fan club. So first of all, you know, the focus on waste streams really has been the focus. You know, cleaning up waste. What do we do with waste? But what about waste as a resource, right? And especially in this day and age, when we have so many supply chain problems, right? We have the problems of getting materials for batteries and all kinds of raw materials. So it's kind of a no-brainer that we should be turning waste into resources, valuable resources. Now I'm gonna couch my discussion in a little bit of background. So Pirelli is headquartered in Italy. The EU has been very focused on circular economy. They have a circular economy action plan, and they're starting to regulate around circular economy, things like making it easier for consumers to repair electronic devices and so on and so forth. So for Pirelli, it's a big focus, and it is coming in part from this regulatory push. And in Europe, there has been producer responsibility for tires for many years in Europe and Canada and some other parts of the world, whereas in the United States, the programs for scrap tires are run by the states, which does have some advantages, mostly in terms of enforcement. But there's similar programs, and basically in Europe and Canada and the United States, all of those programs have actually made huge headway in terms of keeping tires out of landfill. And I'll get to that. But I wanted to start with Pirelli's approach to a circular economy. So this is part of our, overall industrial strategy. These are 5 R's: rethink, refuse, reduce, reuse, recycle. And, there are lots of pyramids about circular economy, recycling pyramids, and so on. But really what's changed, I think, in the last maybe decade is the focus on designing for circular economy. So it's no longer, if we're in a producer responsibility context, it's no longer set up the company to deal with collection and then we go about our business. It's actually now a kind of more holistic thinking about what are the materials going into tires, how can we design using materials that are more recyclable or that are better for some of the other end uses. And I'm going to talk about materials in a minute, but just to go through these R's. So the refuse would be to really focus on what your inputs are. We have a global program to ban single-use plastics in the company. And then reducing resources. We're trying to make tires that are lighter and lighter with less resources. And then, as Ali said, EV batteries are heavy. And so you get a situation where we're trying to make lighter tires, but to support a heavier vehicle. So there's actually a lot of R&D going into that. We're also trying to reduce fossil-based materials and increase renewable materials going into tires. And then reusing, that applies to lots of things, but one example is water, reusing water in manufacturing. And then, again, looking at the materials. There's also been some questions about maybe lengthening the life of a tire, so how can we make all of these things are contradictions, how can we make tires that are very safe, so they have a lot of grip, but also very fuel efficient, so they have maybe less grip. So that's a contradiction there. How can we make them lighter with less resources, but also last longer? And then recycling. And of course, the best case of circular economy would be if we could just take a scrap tire, devulcanize it, and extract everything, and then start over and use those materials in new tires. Unfortunately, a lot of the recycled material today has problems with the level of quality. And so it can be used largely as filler for tires that don't need to perform well, like on off-road tires, agricultural tires, things like that. You can use some of the material as filler. Whereas if you're making tires for Formula One racing the way we do, or just really high performance handling, it's harder. But we are at Pirelli, we are working on extracting materials that we can use in making new tires. And if we go to the next slide. So we look at the whole life cycle, and our strategy is very focused on reducing environmental impacts across the whole life cycle. Raw materials, we use rubber from trees. That's why you see trees in this picture. Rubber comes from trees, just like maple syrup. And so we look at the the environmental impacts there. We are here in Georgia, we have the first tire factory in the world that is certified by the Forest Stewardship Council for zero deforestation from that rubber, the rubber that comes here. But in any case, going through the whole life cycle, we really try to look holistically. So when we do materials innovation, we're looking at not only performance advantages from new materials, but also designing for circular economy. Can you go to the next slide? And so some examples of materials innovation. I talked about, we have goals to reduce fossil materials and increase renewable materials. We have a substitute for silica made from rice husk ash. We use lignin, which is from paper pulp, and recovered carbon black is the material the recycled material from scrap tires that is most promising, and that we're working on, refining the quality and scaling to use more and more in our tires. Next slide. So I think people don't know, a lot of people think that tires go into landfill, but actually they are the second most recycled material in the US. And I have a series of slides here that are borrowed from the US Tire Manufacturers Association, where Pirelli is a very active member, and we're working on collaborative approaches to scrap tire issues, and really advocating for some of the policy framing that would allow more use of better uses of scrap tire materials. So in any case, about 76% in 2019, which was the last year that statistics were collected, 76% of tires entered circular scrap tire markets. So that's a pretty good number, but unfortunately, this percentage is falling because of growth in scrap tire generation. So there's more tires, more new tires and more old tires out there. And that is now outpacing the recovery rates. So let's go to the next slide. So some of the uses of scrap tires here in the US, tire-derived fuel, which powers cement kilns and pulp and paper mills mostly, takes about a third of the scrap tires in the United States go to that. And that is, I think, an important use. Waste to energy, I think, is important, especially if you can do it without emissions or capturing the emissions. And then ground tire rubber is used to produce rubber modified asphalt, landscaping and playground mulch, and athletic surfaces and so on. And automotive parts like mats in the car. And then tire-derived aggregates. There are some interesting uses. You can actually use scrap tires to filter stormwater on the side of the road, and filter out microparticulate, even the particulate matter that's coming from the tire wear particles themselves. Let's go to the next slide. I think so I wanted to talk about rubber modified asphalt. So as I said right at the beginning of my comments, we tend to focus on how can we get rid of waste, but rubber modified asphalt actually makes much better roads than virgin polymer asphalt. And some of the advantages are increased pavement service life, less potholes, reduced road maintenance, which saves money and also saves lives. It's, the roads are safer. There's a reduction in CO2 emissions and better reaction to rain, water, increased skid resistance, noise reduction, better ride quality, and so on. So there are lots of advantages. So this really is an example of something really to look at as not in terms of getting rid of the waste, but in terms of a resource for something very useful to society. Next slide. And then I talked about stormwater infiltration galleries. So tire-derived aggregate from recycled scrap tires can be used as infill material, and it has lightweight and allows for more water volume capture potential and so on, and captures these microplastics. Next slide. So since we're all in Georgia, I wanted to just mention this tire bill. Ali is probably the world's expert on this tire bill. And it did pass the Senate, but did not pass the House in time in this session. So the state of Georgia mandated a switch from from the tire fees collected at retail going into a general fund and move them to a dedicated solid waste trust fund, which is great. And the fund is now being used more for tires and also landfill remediation and also curbside recycling. What this new bill asked for, among other things, was that 10% of the funds be set aside for innovation projects. And so rubber modified asphalt, which is widespread in Georgia already, but could get a boost from innovation funds to allow for getting exactly the right mix in a particular area on a particular road. And I wanted to end with that. And I think we'll get to questions later, right?
That's right. Thank you so much, Maureen. And I'm going to ask Stephanie Valdez-Streety with Cox Automotive Mobility to take us through a conversation about EV batteries and their second life, similar to the discussion that we've just had about tires, right? 260 million trash tires, and that's our floor. We're only going up from there as we electrify. Similarly with batteries from electric vehicles, we're talking about massive acceleration of EV adoption over the next decade and longer. So tell us a little bit, Stephanie, about recycling and upcycling opportunities with EV batteries.
Yes, good afternoon. Thanks, Ellie. Thank you for inviting me to be part of this panel. I'm excited. As you mentioned, I work for Cox Automotive Mobility, and it's a privilege to work for Cox. When you walk into our main lobby, you see banners that say sustainability, mobility, and connectivity. So the conversation about electrification is in line with our direction of what we're doing at Cox Automotive. And so if you go to the next slide, I'm excited to talk about electrification and highlight some of the things that Cox Automotive Mobility is doing in this space. So it's a perfect storm if you think about, prior one. So it's a perfect storm if you think about environmental commitments with the US signing back up onto the Paris Agreement. You have companies establishing carbon neutrality goals, which part of that is electrifying their fleet. And then you've seen in the news a lot of the car manufacturers committing to electrify their fleets as early as 2035. And as Ali mentioned a few minutes ago, trillions of dollars have been committed to electrify all of our fleets. And so that's exciting because it's creating a lot of buzz in the media. And with that, consumers are becoming more aware about EVs and the environmental benefits and also how much they're fun to drive. And we can see this in the uptick in sales. So last year, there was a year-over-year increase in electric vehicle sales at 86%. So it was 1.4 million. However, the number's small, but it's only going to continue to increase. And according to IHS data, it's anticipated by 2030, 35 to 40% of sales will be EVs. So I'm excited about the carbon benefits of EVs, but one of the things, and I'll be talking about this in a minute, is we need to make sure we have a circularity around the caretaking of the EV battery. So next slide. So at Cox, one of the things when we think about electric vehicles, our vision for it is that we believe that the future is not only is it going to be electric, but also connected and shared. And so that's going to be dominated powertrain for both the movement of peoples and goods. And we also believe that EVs are important for reducing greenhouse gases and meeting the goals on climate change. And as I mentioned, companies establishing carbon goals, we also have one established by 2034. In addition, we believe that a closed loop ecosystem for EV batteries is imperative to really reducing the environmental impact of metals mining. And so if we think about this vision, as we are looking at ways that we could play a part in this, we identified an opportunity to really start to build this closed loop system around EV batteries. So last year, we bought a company named Spears New Technology. And Spears New Technology, they're battery experts, and they've been around for a while. They've been diagnosing batteries and repairing them for a long time, working with the OEMs. And so partnering with them, we've established these EV battery service centers. And so basically, this is a one-stop shop where we can start to create this EV battery life cycle support system to really ensure that batteries are optimized in first life, have a second life, and then are properly recycled at end of life. So if you can see on this slide, battery health is the first thing that we do. So a battery comes into the location, it's diagnosed, and based on that diagnostic evaluation, it's determined whether it should be repaired, remanufactured, or repurposed. So repurposed could be a second life application. And usually, as Ali also mentioned, when a battery comes to end of life, there's usually about 80% capacity left. In addition, on some research shows about 7 to 10 years in that second application. And so really looking at where can that be used, whether it's for battery energy storage, grid stabilization, and other use cases. So that's another thing that this location will determine based on that battery health diagnostics. And then finally, if it's at end of life, at these locations, we'll be doing the first stage of recycling called pre-treatment. And pre-treatment basically grinds up the battery and creates this thing called black mass. And then black mass will forward that on to other recyclers. You've probably seen, or maybe not, but in the news, there's some companies, Recycle is one of them, Life Cycle, Redwood Materials. So those are organizations that are really starting to build up partnerships in recycling these end-of-life batteries. And I think it's going to be important as we start to build up this robust recycling, because it's estimated by 2024 or 2025, over 500,000 batteries will reach end of life. And by 2030, 1 million. So it's going to be really important that we start to really build this robust supply chain around EV battery caretaking in the US. In addition to doing all the diagnostics and repair, second life, and recycling, these locations will also do the safely and sustainably store and ship these batteries where they need to go to. So that's going to be another element that we offer at these locations. And then a critical piece that will also be done is battery tracking, which will be a digital record of that thing. And we have locations in Oklahoma, and we're expanding to Detroit, Las Vegas, and the UK as well. And then moving on to another important area that I wanted to highlight that we're doing around battery health is we've developed this battery health score. And the goal is to really create an industry standard around this. Because one of the things that when you have an internal combustion vehicle mileage, there's a lot of data sets that show the condition, the health of that vehicle. For EVs, not so much. So we started this pilot and we developed an algorithm with Spears Note technology, which takes certain data sets from the battery. So it could be the temperature, state of charge, cycles that it's battery energy that's come in and out. And based on that, it goes into this algorithm and creates a score from 0 to 5. And so we've actually tested 1100 so far, so a little updated from that 600. And so far we've seen on average on those vehicles a 4.7 score out of a 5. So we're seeing really good results. The other thing that we wanted to highlight on this is to see how does the health score, how does it impact the valuation or depreciation of that vehicle? And so we've also seen from that data set of 1100 vehicles that those EV cars that have a battery health score are transacting at 1 to 4% more than those EVs that do not have it. So that's some really good insights to have. And I think we're really hoping that this will create an industry standard, but also create trust and transparency in the industry around EVs. And as we think about just the mass adoption of electric vehicles, it's going to be critical that there's a price point on those EVs for everyone, so it's accessible. And so I think having this battery health score and bringing confidence into the resale of used EVs is going to be critical. Next slide. And then just to wrap it up, one of the things is when we think about this circularity around EV batteries, if we really want to achieve the carbon benefits of EV, it's going to be important that we do optimize first life, second life, and end of life. Right now, on average, to produce an electric vehicle, it takes twice as much carbon versus an internal combustion vehicle. And it's only at about 17,000 miles when that car's driven, that electric vehicle's driven, that the carbon's offset. So that's when you really start to see the carbon benefits of EVs. And then, as I mentioned, the end of life is going to be important because we need to really reduce the mining. It takes about 500,000 gallons of water to mine. I think is it 1 metric ton of lithium? Yeah, per metric ton of lithium. So that's a lot of water. So we don't always think about the water impact of EVs. We always talk about the carbon, but there's some water implications. So it's going to be important to really recycle that material from those batteries. Because if we look at, as I mentioned, by 2030, 35, having 35-40% of the sales be EVs, that's going to be really increase the demand of lithium. And I read a study recently, it was from the Institute for a Sustainable Future, and they said if we're able to really improve the recycling recovery rates and continue to do that by 2040, we can reduce the demand for lithium by 25%, cobalt and nickel by 35%, copper by 55%. So it's just going to be very important to continue to do that, so that I feel like when we think about circularity and sustainability, we really want to get that triple bottom line where it's good for the planet, good for the profit, and good for people. And when I talk about people from this, I think from an EV perspective, just the clean of the air. And American Lung Association said with the zero emissions environment, we're gonna, I think they said save, it was like 110,000 lives by 240 and reduce asthma by 2.7 attacks. So I think there's clearly, if we continue to provide this circularity around EV batteries, we're gonna have some really good environmental and health benefits as well.
Awesome. Thank you so much. Thank you so much, Stephanie. I'm going to ask Jamie Zinzer from Novelis to talk with us about aluminum, the forever material, and really one of the most expansive opportunities for circularity in transportation, with the need for lightweighting the bodies of electric vehicles. Jamie?
Thanks, Allie. So just real quickly, a little bit about Novelis. We are the leading producer of flat roll aluminum products and the world's largest recycler of aluminum. We employ approximately 14,000 employees across 33 operating locations in 9 countries. Our aluminum is featured on more than 225 car models around the world, including the F-150, which I think everybody's familiar with, the Tesla Model 3 and Model Y, the BMW X Series, the Jeep Wrangler, the new Jeep Grand Wagoneer, the Rivian Amazon Prime van, and the list goes on and on. So just a fun fact, what's the most valuable material in your recycling bin? It's aluminum. Did you know that 75% of aluminum ever produced since 1888 is still in circulation? So let's keep this going. As Allie mentioned, this is the forever material. And then if you just recycle one beverage can, it can save enough energy to run a television for up to 3 hours. So you can watch an entire movie off just one recycled beverage can. Next slide. So aluminum cans are also the most sustainable packaging in the world, and they can be recycled over and over again. They also chill your drinks faster than plastic or glass. It literally takes only 60 days for a can to go from your recycling bin through the recycling process and back on the store shelf as your favorite beverage. Recycling aluminum is a core component of our business because it requires, as Allie had mentioned earlier, only approximately 95% less energy to actually produce aluminum through recycling versus through primary aluminum. So it's very critical, and that's why it's a major focus for us at Novelis. Next slide. So let's get into the automotive segment. So Novelis is the global leader in closed loop recycling. So what does this mean? This means that we collect the scrap during the various manufacturing processes at the original equipment manufacturers, of the OEMs. We bring this material back to Novelis and for reprocessing. After the OEMs stamp out auto parts, up to about 35 to 40% of the aluminum sheet is still available for reuse. So this is a very significant amount of scrap that's produced during the production processes. So the fact that we bring this back, this process preserves the value of the alloy, minimizing environmental impacts and establishing a secure supply chain also for automakers. Today, recycled aluminum accounts for about 61% of our manufacturing inputs globally, and we're constantly working to increase that figure by investing in additional and new technologies and developing alloys that can accept higher amounts of recycled inputs. So just to give you a couple little case studies here, next slide. So I think everybody's familiar with Ford. So we are strategically positioned right now to obviously help all of our global customers achieve their sustainability needs through design practices and also manufacturing practices. As an example, we have partnered with Ford to develop the world's largest closed loop recycling system. As you may be aware, the revolutionary 2015 Ford F-150 launched as an aluminum intensive vehicle, improving performance and also saving up to 700 pounds of weight per vehicle. This enabled them to also pursue the closed loop recycling benefits. As a result, Ford recycles and reuses more than 90% of its aluminum scrap, which is enough to produce 30,000 additional F-150 truck bodies each month. So it's pretty significant. Another very interesting case study is with Novelis and Jaguar Land Rover. So Novelis collaborated with JLR to create the first closed loop recycling system in Europe with a dedicated railway system to efficiently deliver aluminum between Novelis, the Nettershop plant, and recycling center in Germany to JLR's production site in the UK. So this railway system has resulted in a 80% reduction in CO2 equivalent emissions compared to road transportation of similar materials. In 2016, JLR reclaimed 50,000 tons of aluminum scrap, which is equivalent to about 200,000 Jaguar XE shell bodies. This is extremely impressive that we are able to collaborate with JLR in this area. The emission reductions achieved through this effort prevented 500,000 tons of CO2 from entering into the atmosphere. So JLR and Novelis won the prestigious European Aluminum Award with their work in this area through innovation in the closed loop recycling system. So we're very proud of this and very excited. We're currently engaged with other customers and hope to be able to share additional success stories in the future. Okay, next slide. So we continue to develop new alloys and optimize existing products with higher percentages of recycled aluminum to meet our customers' needs and enhance sustainability efforts. We are also seeing a need for increased circularity programs that offer customers more solutions to help achieve their sustainability goals, to increase the amount of recycled content and reduce the use of primary aluminum, which is more carbon intensive. Novelis leads the industry in increasing the number of scrap it brings in, which means getting production scrap back from customers as well as other consumer areas. So we look forward to continuing and shaping our sustainable world together and obviously partnering with the Ray and Cox Automotive and Pirelli Tire. So thank you very much for having me today.
Thank you, Jamie, so much. And it's an honor for the Ray to be able to work with these three companies, and an honor for me and the staff of the Ray to be able to work with these three leaders in the industry. Just to recap, we started this conversation with the question of why is now the time for circularity in transportation? Why now, right? We've seen circularity take off in all of these other global sectors. Why now for transportation? And we've talked about the historic infrastructure investments. We've talked about the transformation and the disruption in the industry itself as we go electric and as we go connected and autonomous in our mobility. But my observation of the last 40 minutes of conversation is that the other answer to that question of why now is that circularity enables us to touch every portion of this industry. So we've talked about, for example, the supply chain, the imperative for recycling materials out of end-of-life batteries for new batteries because of the reduced reliance on new materials mining. That is an imperative, as Stephanie discussed and demonstrated, that to meet the demand of electrification in the United States, we cannot rely simply on mining those materials. We have to rely on circular models to get materials, the minerals and the metals out of old batteries and into new batteries. Similarly, again, on supply chain, aluminum in any form, scraps on the manufacturing room floor, aluminum beer cans, any of those sources of aluminum can be forever upcycled into new light-weighted bodies for electric vehicles. And again, as we scale up the demand and as we meet that demand with different types of models at different price points for electric vehicles, we've got to have the supply chain of aluminum to lightweight the bodies of those electric vehicles. On the infrastructure side, Maureen with Pirelli Tire talked about how scrap tire waste streams will increase. That is a known, and they may increase significantly in the short term while we re-engineer tires to have more durability for electric vehicles, right? Given the weight, given the instant torque, given driver behavior, all of those things. We have to redesign the tires, and Pirelli's on the cutting edge. But in the meantime, we're going to see significant increases in the tire waste stream, and that's where infrastructure comes in. We can build high-performing, resilient roads using scrap tire rubber, also using tire-derived aggregate, and we can even look at applications to clean our storm water in the transportation sector using tire-derived aggregate. Lastly, infrastructure for energy. Stephanie and Cox Automotive are on the cutting edge of taking end-of-life batteries from the electric vehicle supply chain and looking for opportunities in the energy sector for grid storage that redeploys the 80% or so of remaining capacity in those batteries and redeploys that into the reliable, resilient storage of clean energy for America's grid. So all of that answers the question, why now? It's an imperative. It's an opportunity that cannot be missed. There are economic and environmental gains. It's the best of both worlds. And our namesake, Ray Anderson, would have approved all day long of taking the scraps off the manufacturing floor and putting them back into new products, just like he did with old carpet and carpet scraps going into new carpet tiles. We've already got questions in our Q&A queue. If you are listening to this webinar, this is your opportunity to ask a question about batteries, tires, resilient roads, and aluminum body frames for electric vehicles. I'm going to actually start us off with moderator privilege here, and I'm going to ask a question for all three of you. I'm going to start with Maureen, and the question is, I'm just curious if your companies think that a carbon price is going to incentivize circularity and incentivize the use of recycled material. Maureen, let's start with you.
So my company has declared itself in favor of a carbon price and uses an internal carbon price just for accounting, because I think what this speaks to is two things. One is the idea that we can no longer, as companies, we can no longer take free things from the environment and and not pay, and then externalize the damage onto society, onto taxpayers, other companies, and so on. And so more and more in the sustainability arena, companies are being asked to report on our impacts on society, on the environment, and so on in our annual reports. to investors. So there's a big push from investors on that. And then the second part of that is incentives for different behavior. I don't know that we need that as an incentive, because as all of these examples pointed out, there are cost incentives just from, I mean, these are innovations that that actually save money for companies and also solve problems. But some sort of alignment or some sort of harmonization of how these sort of nature costs are accounted for might be helpful, whether it's a tax or just an accounting, an accounting rule or something like that.
Great, thank you, Maureen. So it sounds like Pirelli Tire supports a carbon price, but does not think that it is a necessary incentive for circular economy practices in transportation. How about you, Stephanie and Cox Automotive? Does your company have a position on carbon price?
No, I can't expand on anything right now on that. I do know that our VP of Sustainability, Ira Pearl, he came on board a couple of years ago and really put together a new strategy in place around sustainability and came up with our new goals around carbon, water, and waste. And I know he's been having conversations around that, but at this time don't have a statement to make around that.
Okay. Jamie, what about Novelis? Is a carbon price an important incentive for circularity? How do y'all see it?
I guess what I can comment on is that both internally and externally, so internally, projects that are offering more sustainability and helping us achieve our goals are incentivized, as well as the customers who are willing to cooperate with us in closed loop recycling initiatives and things of that nature. And looking at different alloys with higher recycled content, they are also being incentivized. So I can't basically give the particulars, but yeah, that is a primary focus for us.
Let me ask Stephanie a pointed question about electric vehicles, something that comes up quite a bit. So what is the environmental impact of building electric vehicles? And more to the point, are they really greener than internal combustion vehicles?
Yes, thanks, Allie. I actually did a white paper last year on the environmental and health benefits of EVs. And so based on that research, and as you know, things change like every month, but based on that data, on the average, an EV has half the carbon emissions as an internal combustion or ICE vehicle. So I think in the long, cradle to grave, EVs are better and they're going to achieve the really good carbon offsets. But as I mentioned earlier, it takes twice as much carbon to build the EV just because of the mining and all the other stuff and the production. And so it's going to be important going back to recycling, do less mining. And then the other thing that impacts it is the grid. So as we continue to green the grid, that's going to be another factor that impacts the overall carbon or green impact of an EV. So I think those things, reduce the mining, greening the grid, and making sure that we're optimizing that battery on that EV so it's on the road as long as possible. Because the longer that EV is on the road, the more carbon savings we're having per EV.
Great. Maureen, a question for you from the chat regarding tire-derived aggregate and rubber modified asphalt and their costs. You mentioned that the costs of modifying binder for asphalt road building using scrap tire rubber material over the life of the road, and also as it competes with polymer modified asphalt, you're actually looking at a savings in using rubber modified asphalt. What about tire derived aggregate, and does Pirelli Tire have a different opinion about the benefits of tire derived aggregate in road building versus rubber modified asphalt and the costs? And Maureen, you're on mute.
Thanks. So my understanding about these things, and we in the Tire Trade Association we have experts. My understanding is that tire-derived aggregate is used for things like preventing erosion and landfill cover, things like that. I think both. So I think it's not. I think tire-derived aggregate and rubber modified asphalt are two very good uses. I think that I saw the question in the chat, and it sounded like there was also a part of the question about how much scrap tires, how many scrap tires we could use in one or the other application. And my understanding is that if we really stepped up rubber modified asphalt and put scrap tire material in all the roads, as they are actually doing in California, they're doing that for all major roads, that would really take care of a lot of the problem of the scrap tires. And I don't know exactly how many applications there are for tire derived aggregate and what the volume is on that. But I think both of them, my understanding is that both of those are really good uses.
Great. And I think we've got time for one last question. Jamie, I want to start with you. What kind of trends are you looking at in the transportation sector right now? And are there any trends in particular that speak to the circular economy or circularity advances in transportation?
Yeah, so I'm going to kind of add on to the question that you asked Stephanie too. Maybe try to combine the two, because I think one interesting point here is with electrification, what this enables the OEMs to do is actually look at things from a very blank slate, clean paper approach on how would we do this right, and how would we do this right considering sustainability. So things like, okay, we have to redesign the vehicle anyways, because the architecture is completely different. I know they're using, lighter materials, we're going to see a lot of EVs are going to be very aluminum intensive, but it also enables them to think, okay, how can we design this in a better way? And, we're not basically, we have to redesign our manufacturing processes anyways, so we can think outside the box here. So you see a lot more conversations associated with, looking at recycled alloys, looking at alloy concepts. What that means is designing a car, like for instance, let's take a door with an inner and outer panel with like material so that it can be recycled easier. So these are the types of things that the EV segment has actually enabled more sustainable practices from a design and manufacturing process, not only just the closed loop piece of this. So I think that's it's going to be a very good trend on a go forward basis.
Yeah, Ellie, I wanted to add,
go ahead,
Jamie,
Stephanie.
that was right on spot. And I was going to add, part of what I'm seeing is the collaborations, right? The more and more collaborations around this, because the only way we're going to achieve the goals around circularity is around collaborations. And so I really see a lot of that happening more and more.
Absolutely.
Maureen,
Yeah.
same question to you. What trends in transportation are y'all watching at Pirelli Tire? And you in particular, as an expert in sustainability and circularity, is there any trend in transportation that is going to open up even a new door for circularity in the transportation sector?
Well, one of the, so I think there are two big drivers for Pirelli for sustainability in general. And one is investors and the other is the OEMs. And so the OEMs are really stepping up requests for tires with more circular economy attributes, and to go into vehicles with more circular economy attributes. And we, like everyone, we're watching those electrification, the connected, the shared, and so on. And so we have a sensor for tires that can speak to the vehicle and bring information. And so all of that ties in with better tire maintenance, which is, again, part of the bigger picture of sustainable and safe tires and vehicles.
Awesome. We've got about 3 minutes left in this webinar, and that means that I have time to squeeze in one more question. Jamie, you gave us a couple of amazing examples of how Novelis enables customers like Jaguar, Land Rover, and Rivian to meet sustainability targets. So this is lightning round, beginning with you, Jamie. Any other examples of how Novelis is supporting customers to meet sustainability targets?
Yeah, I think one thing that hasn't been mentioned, and Stephanie touched on it a little bit with the whole recycling of batteries, but there's going to be a need and a push in the future for also end of life initiatives. So, not only the batteries, I think the batteries are going to be the enabler here, but then, what do we do once all these vehicles start to expire? And, what technologies are going to come into play to help promote more end of life initiatives?
Stephanie, lightning round question to you. Cox Automotive with battery health rating and battery recycling, how are y'all enabling your customers to make this transition, achieve sustainability goals?
Yeah, I think part of it's really the educational piece, especially with our dealer customers, really getting them to understand how to prepare for electrification and the importance of battery health as they're trying to sell these vehicles at their dealership. So I think really educating them on the different EV journey life cycle is something that we're focused on.
Awesome. And Maureen, to you, Pirelli Tire, how are you helping your OEM customers and other customers to achieve their goals?
Well, it's I think things are accelerating rapidly. I just talked about I talked about a few of them, but we provided BMW with the FSC certified tires, and more we're getting specific requests, but also sustainability aspects going into the purchasing choices of the OEMs. And for the first time, I've been brought into some even product development questions. So sustainability is really top of mind for the OEMs, and they're bringing in, I think, all of their suppliers to the conversation.
Thank you, ladies, so much for joining us for the last hour. We have been so pleased to host this webinar with you. And for those who joined us, thank you for being with us. Your questions, if they were not addressed, will be addressed by email, and we will stay in touch because we're going to continue to talk about circularity and transportation as these opportunities unfold and take root. Thank you.
Thank you.
Thank you.